Don't worry, you haven't missed the show. I just pressed the wrong button. I'm a damn fool. I do apologize. Hey, welcome to this month's IoT North Meetup. This is our technical monthly show. We've got some great speakers lined up for you today. We have Vision Intelligence's CEO, Krste, sharing his experience with IoT manufacturing using vision as a sensor. And we have the CEO of Krste Energy from the US talking about how to unlock innovation with supercapacitors. Without further ado, I shall bring the guys in. So we have Joe Sleppy and Krste. Krste, I'm not even going to try and pronounce your surname. And we've also got my good friend John Staveley, who helps with the community here as well. Guys, thanks very much for joining us. Great to have you with us. Just a bit of housekeeping. IoT North, we're a community here. We're here to help you. We've got the website, iotnorth.uk, which we've advanced for your benefit. So please do sign up for the forum. Join us there. Start the conversation. Connect with everybody. We're all here to help and accelerate the adoption of IoT. That's the whole point of this. And we also have the Solution Marketplace, which is free to register your use cases, and then we'll promote them socially for you. So please do get them registered on there. We've got about 30 use cases on there now, some really good ones, and we're getting some good traction of interest. Interesting, public sector seems to be sniffing around the website, looking at the use cases quite a lot. There seems to be opportunities for building business cases to get your IoT adopted there. Manufacturing seems to be really, really hot at the moment as well, which I'm pretty sure Chris will agree with on that one. There's an awful lot of funding and grants available with stuff like Innovate UK. So, you know, that market's finally starting to really build up the traction and start to remove the barriers there as well. So, Chris, would you like to do a little bit of an intro on yourself?
Yeah, hi. Thank you very much for having me on tonight's show. It's really nice to be here. My name is Krste Pangovski. I'm the CEO of Vision Intelligence. So I guess by way of a personal background, I actually came from a very long sort of journey in user experience, then kind of morphed into physics and engineering, and now working in artificial intelligence as applied in manufacturing particularly. So quite a sordid background on my part.
Sorted indeed. Hi, Joe. How are you, sir?
I'm doing good. It's been a really good time to be here and meet with you and talk to the rest of the community.
Great. Would you like to just give us a very little snippet of Krste and what you guys do?
Yeah, absolutely. Well, my name's Joe. I'm the CEO of Krste Energy. And when I was a sophomore at the University of Central Florida, working on my electrical engineering degree, I was doing undergraduate research on perovskite solar cells and energy storage technologies. And that's where I was exposed to this wire-shaped energy storage concept, which is what Krste is working on. And I fell in love with it, licensed the intellectual property from the university, got a couple grants, won a couple competitions, raised some money from investors, and took the academic theory and concept to a real working product that's being produced in Orlando, Florida. And right now we're starting to get a lot of traction in wearables and IoT, and that's because we have a flexible energy storage technology, which is required, right? Energy storage is in everything. So why not make it flexible and better integrated into the system so that more features can be added in new places?
Awesome. Really looking forward to your talk a little later. John, how are you doing, buddy? What have you been up to this month?
Good. Arguing with Azure IoT. I've been building some devices. As you can see, it's sort of prototype stage. It's a little hit and miss. You know, lots of fun technical projects coming out, and fireworks coming out of my room. Potential talk coming out of it soon.
Fireworks.
I've also been trying to bait you on Twitter. I put on the IoT leads. There's this video of this person who's doing all this review of all these devices, single onboard devices, and he was saying Raspberry Pi is definitely the leader of the field and there are no competitors, which I thought would gain a response from you, but not very disappointingly, nothing from you.
Yeah, well, it didn't get a response from me because I'm no longer at 8A-Link as of last week. So they can pick up that battle with single boards and discussions on those points. I've had some really interesting conversations, funny enough, about single board stuff recently, and you know, or the sort of debate on is is Raspberry Pi usable in an industrial space? Where there seems to be some people that believe they are, and some people believe that they're definitely not. If you have a view, please do mention that in the comments on the social platform that you're on. We'd love to hear from that. Just say hi. It'd be great to know that you're there. Although I can see numbers picking up. For today's shows, the guys have asked that we'll answer the questions once they've finished their talks. So if you do, please do ask as the show's going on, and then I can bring those questions in. So simply just do that by commenting in the comments on Facebook, Twitter, YouTube, or LinkedIn, wherever you are. And without further ado, Chris, we'll start with your talk.
Okay, hi, thank you very much. Okay, I guess I need to share my screen first. Let me just make sure that that's all well. Paul, if you just might let me know if you can see it, fantastic, and I'll make it full screen. I'll go ahead. Okay. Right. Thank you very much again for inviting me this evening. It's really nice having spoken to you a couple of times in private to be able to kind of discuss what we're doing over at Vision Intelligence. So the topic of the talk today that I wanted to discuss really with everybody is the potential of unlocking the DNA of any assembly process using artificial intelligence, with the purpose of taking one step towards this coveted goal of zero-defect manufacturing. But actually, to start off with, perhaps the right thing to do would be just to tell you a little bit about why we're working on this in the first place. The reality is actually that there are still some 300 million people globally working in factories, manually assembling things, very much contrary to this, I guess, popular belief that robots have taken over. That simply isn't the case. We've seen the likes of Tesla, the likes of Apple try to apply robotics and automation in areas that really require the level of dexterity and skill, and in fact, tacit knowledge that has been honed over a whole generation. And they have spent astronomical amounts of money to very little advancement in that area. We are, however, seeing companies like Boston Dynamics making real leaps forward in terms of the flexibility and so on. But how that really translates in terms of operations that require the level of real-time decision making will ultimately be decided, I think, over the years to come. But for the time being, we do believe that humans are very much the integral force in manufacturing, and account for some, to say, one of every $2 that is created on Earth within the manufacturing arena. But we do have a problem, and that is that there's a whole generation of skilled manufacturers that is heading for retirement. And the global manufacturing community, we believe, Vision Intelligence is not strategically positioned to deal with that. Luckily for us, factories are a very rich source of visual data that is going to, we believe, enable us to capture those skills and create a productivity improvement that is based on real-time and data-driven decision-making, which is what our IoT stack, if you like, is geared to do. So without further ado, let me tell you a bit more about what it really is. So human beings are what we might consider a bit of a blind spot to analytics. And the reason for that is because the sensors and things like that have been created have very much been focused on the machines and the automation and various automated production lines that currently do exist. But we asked ourselves, so what if we could, to some degree, digitize human activity and bring that together in a service that helps the people who work in manufacturing improve their skills, ensure the products are created according to standard operating procedures, ensure that the traceability is correct, and so on. And what our system does, Violet AI, what it does is it digitizes human activity. And I'll show you this video on the right-hand side. Videos aren't working very well at the moment on my. But as you see here, the video that you see in front of you is actually the Violet AI system looking at somebody assembling an aerospace component with composites. And on the right here, you see that all the various steps that we have taught the system to recognize that form the full manufacturing process of that particular part. And as the activities change, you'll see at the bottom here that the system is now creating this fingerprint or the DNA of what is actually taking place on the production floor. So if I just kind of go ahead a little bit, you see how it changes as we go along, depending on who's doing what. It's creating that full record of what is actually happening. And now, if I can just say that what that ultimately allows us to do is to provide a data-driven approach to productivity improvements based on human activity that's taking place at the factory floor. Now, this is one of this assembly DNA, and if you've ever wondered what the DNA of an aircraft tire looks like, well, that's what it looks like. And the great thing about it is that we're actually taking quite a holistic view of the way people create objects and parts and assemblies and ultimately entire components and products by asking our AI to understand questions that a human being would try to understand. So, for example, what activities are people undertaking when they're building an object up? What is the state of that particular assembly? And what are the parts and items and tools, that are there? And what are the environmental conditions? All of these things are really important within manufacturing, particularly when you have that high degree of manual intervention in an assembly process. And by being able to use our IoT edge artificial intelligence to answer those questions, we are able to create this kind of fingerprint, which is when we move to the core AI. And what the core AI does, it looks at the fingerprint and tells us whether, for example, there is a defect because it can recognize those patterns, or it can recognize that somebody's perhaps, stopping a bit too often, something like that, and saying that perhaps there's a training opportunity there. It can also highlight things like process instabilities and separation or disadherence from the standard operating procedures and many, many other things. So that is the overview of this Violet AI technology, and essentially, what it really looks like is a little IoT box like this. That's brimming with all sorts of wonderful sensors and so on, that essentially is able to do what you're seeing on the presentation screen right now. So what are we building more broadly? Well, we think we're building something really quite spectacular for manufacturers, and particularly SME manufacturers. Why SME particularly? Well, because quite often SMEs are absolute experts at the thing that they do, but they don't necessarily have all the skills to, for example, buy a bunch of Raspberry Pis and convert them into something that's going to be useful, integrated with their existing IT infrastructure, if there even is an IT infrastructure within an SME. So what we provide is a full service stack that consists of essentially what we look at as 3 layers. First of all, the physical. So that's the IoT, so the industrial IoT shop floor data capture layer, and that consists of a number of different devices that look at, for example, the Violet MK3 and the Violet 5G. They both essentially do the same thing. That they digitize human activity. But there's other devices that we're also using for perhaps more automated areas in production, such as the Holocam, which is a holographic interferometric system. There's also a gigapixel system on the right hand, but also a variety of other telemetries that our partners at Infield Solutions are working with us to deploy and to show the benefits of. The next layer, we, as part of that fully integrated view of IoT, but for SMEs, we develop applications that deal with specific business challenges, so that the SME can actually just pick up a fully integrated solution without needing to worry about, am I going to be able to integrate it with this, or do I have to develop something, and so on. So these are all the questions that SMEs are asking themselves when they're on that beginning of the upward trajectory in the digitization journey. This is very, really, I think, important to realize for everybody working in IoT and more broadly in areas such as industrial digitalization and so forth. And of course, finally, the transition between the shop floor and the application layer is done through our core AI. So that this is the part of the artificial intelligence that then converts all these incredible data from the systems and the applications that run on the edge artificial intelligence systems that we build to provide actionable input into their organization and provide data-driven improvements in productivity, quality assurance, training, and so on. So now I just want to show you a very brief video of how I believe a deployment should look like. So we had a very, very good colleague of ours from the University of Cambridge. He was a student, Alexander Stoilov, that worked with us for a few months to develop some very interesting AI vision system. But the point of this video really is to show that we need to take a holistic approach to deploying, as well as all the clever things that our systems can do. Being able to get into an operational environment and deploy the solution with minimal or zero interference with live production lines is incredibly important. So if I can just play this video, just to also give a big shout out to my man Alexander Stoilov, who helped Vision Intelligence very much during his Met 2B, I believe, project during the summer.
My name is Alexander, and I'm a manufacturing engineering student at University of Cambridge. I'm doing my 4th year project with Vision Intelligence, and today we're deploying advanced computer vision systems at Dunlop aircraft tires. Looking forward to it. Today we're also deploying some telemetry to help us understand the conditions in which the tires are being manufactured. We're deploying temperature and humidity sensors to ensure that we have full visibility of the product environment.
So the point really that we were trying to make there is very much that if you're going to be deploying things like this in a production environment, you need to do this with the absolute minimum disruption to any production, because you've got to bear in mind that manufacturers at the moment in the current downturn, there's very little time to actually put a production line on pause, but they are, however, simultaneously becoming more open to innovation, and that is very much what we're seeing. But of course, deploying these sorts of things, there has to be solid ROI to go with it. Manufacturing is very often very much a bottom line driven game, and we give ourselves very hard targets of applying our systems in the broadest sense to make sure that there's an improvement in yield, improvement in utilization, and reduction in training times, for example. The wider benefits, and I think this is also the way more broadly we need to think about when we apply any kind of IoT solution within manufacturing, is that we need to take a holistic approach, and that's really about looking at the people, the parts, the process, the plant, as well as the partners, which often is something that's overlooked in terms of things like visibility of production and so forth. And I think being able to talk about these things to your customers and so on is actually incredibly important. So just a very, very quick thank you to everybody at IoT North as well, and of course, and my colleagues at Vision Intelligence, and as well as our partners, collaborators, and clients as well. So thank you very much. And if anybody would like to discuss anything further, perhaps offline, then please do scan this, and you'll be able to get hold of us very easily. So thank you again.
Awesome, thanks, Chris. I'm just going to take everybody off mute there as well, so we can have a bit of a chat. Joe, you'll need to do yourself. It's not letting me do you for some reason. Hey, yeah. So that was absolutely awesome, Chris. You know, we've chatted a couple of times about the use of vision with sensors, and it seems to be really hot in the manufacturing space. Why do you think that is?
Part of it is I do believe that to some degree, some of the technologies have actually become commoditized. Okay. Mm-hmm. However, the challenge, meaning that people who are able to, let's say, manipulate these technologies are able to extract at the very least data from them. The reason why we're seeing a lot more activities because as a result of some of these projects, we're seeing the value being brought, much closer to what the manufacturers would expect. But that barrier still remains. So there's very much a kind of an excitement around it. And in fact, I was just earlier on today, I was part of a panel discussion in Eastern Europe, the Serbian AI Society. Then we're talking about the advancements and the big changes that are about to happen, particularly in the vision space. Mm-hmm. And that is because we naturally think about us as humans. We are very visual people, and abstract data is often quite difficult for us. But vision technologies are now to a degree commoditization of certain vision technological aspects is allowing us to become closer to that data and see the insight that it's able to provide.
Yeah. Yeah, I think it has the accountability and stuff as well. And I think one of the things that I find really exciting with vision over the past couple of years of working with it is the layers that you can put on the models as well. That actually you can be monitoring multiple things with the stream of data of the video as well. Whereas if it's a temperature sensor, it's a temperature sensor. Whereas you've got an awful lot of things that you can do with vision.
Very true. If I can add something to that. You're right. A temperature sensor is a temperature sensor, but it also depends how you want to view the data, because any single time domain signal can actually be seen as an image, right? So you could time domain image, look at a spectral response, and then suddenly you get essentially a time domain image or a video, if you like. Okay, and what are all the models that have been developed recently particularly good at? They're very good at at picking out patterns in visual data streams, so such as videos, if you like. But if you can convert the signal like time domain signals that have a bandwidth response, you can actually turn them into a spectral representation. But suddenly you've got again vision, but in a different sense. So it's a lot of amazing advancements in both the hardware, the software, and then actually more and more the applications. And that's really why I think they're so hotting up so heavily.
Yeah, I think we chatted about it a couple of weeks ago that there's a potential opportunity with Northumbrian Water monitoring the pipes for leaks. That actually you could use the vision side of things with audio waves. And monitoring the changes there with the audio waves to start to find anomalies and find it that way, because you could potentially have a good length of the pipes to monitor and collect that data. We haven't had any questions come through. If anybody has any questions, please do ask them. Well, I was just about to jump on to Joe and John with the questions. But if you would like to ask any questions, any of the viewers or anything, please do just simply add them in comments. We will bring it up on screen and we will answer them. Joe, fire away with your question.
Sure. Yeah. Well, Capacitec is manufacturing wire-shaped flexible supercapacitors, and I don't know if you know this, but that's not something that you can buy at Walmart or a retail center to buy a flexible supercapacitor making machine. And so we've designed processes and we've trained people how to do it. We use vision systems in several key areas of our production line to make sure that we got good quality assurance and things of that nature. But one of the first steps to setting those vision systems up is training it. And that was the thing that my mind kept going back to. And maybe you mentioned it and I didn't quite understand, but could you walk us through what it's like to actually set up one of your vision AI systems in a manufacturing facility?
Yeah, absolutely.
Great question.
Yeah, spot on. I mean, one of the biggest problems is how do you get the data to teach an AI model? Well, the great thing about what our system does is that we, by essentially observing what somebody is doing, we can disambiguate the video into key components. Okay, so it takes once of let's say the most experienced operator to do it. Okay, and then because the AI then separates out all that into specific components, like what does it mean to screw in something? What does it mean when somebody's bending a wire? What does it mean when somebody's stretching a bit of composite, and so on? And from that point on, the system becomes effectively autonomous, and it constantly relearns and relearns and relearns. Mm-hmm. So we've actually had, depends on the complexity of the process. The certain processes we've been able to get the AI up and running autonomously within a matter of hours. But I can, we haven't had a use case yet. We're putting together something like a jet turbine engine, which is horrifically complicated. We haven't had a chance to do that yet, and I expect that the cycle time to get the AI to be good enough to do that would be longer. But certainly on certain, should we say, simpler, or let's say not simpler, but perhaps less complex cases with, let's say, a fewer parts and so on, they can be done within a matter of hours. Yeah.
Very cool. Very cool.
So with the process, how do you guys do it? Do you set the camera up on site, start to record, and then take it away and then work it with the customer on what you see?
It's exactly that. It was interesting. We went through a couple of iterations of what the user experience should be, and this is something that, again, must not be overlooked when you're dealing with manufacturers. Manufacturing systems are for by and large, very far behind in terms of their usability and people's ability to learn them very, very easily, if you like. Mm-hmm. So, like I said, we went through a couple of iterations of this, and what we realized is that it's an operations manager who, let's say, knows the process isn't going to just sit there waiting for looking at something and go, that's it. No, they're gonna press start. They're gonna go away, and then the system's gonna notify them when it's kind of finished recording whatever they want to record. And at that point, they go through and go, right, that's that. Train. See you later. So you have to always take into account the user experience aspect of deploying things like this on a production environment.
So. What are the, some people do have a bit of a fear about being recorded and cameras monitoring them. And, the interesting thing with using vision is the camera's only seeing what you teach it to see. Whereas, a lot of people are very conscious and worried about facial recognition and so on, and the potential misuse of it as well. So how do you help take those barriers down with your customers?
Yeah. So at the very outset, we make it very clear that our technology is not in any way intended to displace people, okay, or put them out of work or anything like that, because these are the sort of kind of thoughts and conversations that take place. We've done a lot of user research into this to try and understand those fears. Mm-hmm. And I would boil them down to a couple of things. First of all, mentioning something like AI within manufacturing, which is an industry where typically the production worker let me put it a different way, where productivity has often been paid for by the comfort of the worker and well-being of the worker, is something that we're acutely aware of. So we make sure that whoever we work with, that they're using the system for essentially the right reasons, which is essentially making sure that the quality of the products is good, and to ensure that their operators and production workers are given the right kind of training. And that's one of the things that we want to do. We want to promote AI as a force for good in manufacturing by ensuring that what it does do is that it acts as the operator's little helper and is always subservient to the human. Okay, yeah. Think of it just as like, do you remember those little Tamagotchi toys we used to teach them? Yeah, basically that's what it is. The AI will never ever be if you like the master to people. That is absolutely not what we're building, and we ethically are bound not to.
Yeah, brilliant. John, I believe you had a question. I'm just going to take you off mute because there seems to be a little bit of
I was just thinking during your talk, you said you're doing real-time analysis. How much of the image image, the training of the model is done at the edge, and how much is done cloud, remote, somewhere else?
So, yeah. So the what we call the edge AI model. So that's essentially, you know, all the AI that needs to take data from the environment and let's say visual information or sensor information from the environment and turn it into usable data. That is all done on the actual devices, because potentially every single use case could be slightly different. So, you know, for example, one of these could be looking at a particular, production machine. The next one might be looking at a different production machine. There could be so many. So what we want to do is to make sure that each of these is also, if you like, geared towards the person that it's working with, if at all possible, so they can actually be, you know, helpful. So what we don't want is to have this like one core AI pushing it out, to every other device, because the use cases differ ever so slightly, because people are slightly different.
I'm just thinking you must have some pretty beefy devices there to do real-time training of your model.
Yeah. they're pretty good.
Excellent. And final question is, what sort of benefits have been realized working with your customers?
Okay. So one of the key things we want our customers is the ability to trace. So their products have a very long life cycle. Okay. And depending on exactly how that product is made, will to the degree determine its longevity. Now, we're right in the middle of essentially proving that. So ask me in about 2 months' time, and I'll be able to tell you. But broadly speaking, the key benefit with this particular customer is around being able to trace back potential variances in the longevity of the lifetime of the product, all the way back to a particular activity or a tool set and things like that, through the utilization of the fingerprint. Yeah.
Right. Okay. Interesting.
Great question. We've got a question from Boyang. Hi, Boyang. Would you share some your thoughts about how to switch your role from a researcher to an entrepreneur? Any challenge to commercialize the IP inspired from the research?
To who?
I'm directing that to you, sir.
Oh, right.
Joe
Okay.
could answer that one as well.
Yeah.
Well, yeah, that's what because both. Joe, do you want to go first? I think yours is perhaps more directly what happened here.
Yeah, I would say so, considering we licensed in intellectual property from the university. While I was doing research in the lab, I understood why we were doing certain kinds of work, and the certain kind of works a lot of time was to make sure that the paper was impactful and on the leading edge. But then the commercial market isn't on that same edge. And so I think that the first challenge you have to do is distill down your technology or your research project, whatever it might be, to understand what is actually adding value versus what is some added things that you did to be on the leading edge of research. So for example, if you were making a artificial intelligence vision system, just going off of the scenario we're talking about here, and you had something that was great, but it's only 15% better than what's available in the commercial market, but it's pretty much on par with what is being done in research paper. Your first challenge is to figure out what is it that you're doing that's different from the other research papers and protectable by intellectual property, but not a extra and excessive added benefit that makes your product so expensive that it can't actually be adopted by the commercial market. So watering down your innovation and your research to the most impactful and key components of the technology before trying to take it to the market is a really good step. And I would say the best way to do that is to go talk to actual potential customers and ask them, what problems are you having? What do you like about current solutions? What do you not like about current solutions? And that becomes your answer key. Get rid of the things that they don't like and keep the things that they do.
I think that's a great point. Validation is so key. Getting out and actually talking to people, removing that presumption. It's one of the habits that I've seen quite a lot over the past few years, that as technologists and being very driven for technology, we make technology for technology's sake, and then wonder why nobody wants it. Whereas actually, if we'd gone and asked the customer, we could have probably made 20% and made a lot more money, because we were actually solving a problem that the customer was really looking for. I've got some very interesting question statements coming through now. CJC, I'm surprised there is a big enough use case for this. Sounds much like a big brother for production line workers might end up having the opposite effect on production. Over to you on that one, Chris.
Absolutely. Interesting, CJC, that the comment that you made just a couple after, might money be spent better spent towards actual automation? Well, this is exactly what we're trying to avoid, in fact. So remember the beginning of my discussion, I said that skills are leaving very rapidly the manufacturing base because of retirement, because of downturn in the economy and things like that. And what our system is able to do is to pull those skills in, so we can then disseminate them out and actually, if you like, upskill and reskill and retrain the workers. So that is really the purpose of it. Now, I do absolutely see that you might ask that question, and of course you're very correct in asking that question. And the important thing to recognize here, of course, is that yes, there is a big enough use case. The 300 million people still, working on manual production lines. But is it a big brother? Well, no, it's your brother. It works with you. Yeah, that's the entire point.
I totally agree with you. Also privacy and employment contract issues. I haven't actually come across that as a problem as part of an employment contract. I don't know if you have.
So it's interesting culturally, right? Depending on which part of the world we speak to, we get very different answers. Here in the UK, it's quite pragmatic, actually. You got to remember the UK has got one of the highest CCTV coverages on earth, and London. I mean, let's not even go there. That is literally
like literally
80 cameras or some. I've got silly numbers. But we here, certainly in the UK, we're very used to being on camera all the time. Okay, that alongside with perhaps this need for a certain degree of remoteness, COVID, etc., and people, I think that we're starting to see a shift in what we're willing to accept and what we're not willing to accept. And suffice to say that there will always be resistance to these sorts of technologies. And it is our job as the technologists to make sure that they're a force for good and that they're developed, deployed, and used in an ethical manner.
Yeah, and it's going back to I think from my experience, it's been about education. It's been when we've done projects in the past, my previous employment stuff, when we went down on the floor and we talked to the people that were actually going to be positively impacted by this type of technology, and talked to them about it and gave them the understanding and showed them that we need to record this to teach it this, and that's all it's going to do, then that's all good and well. Not quite at the Skynet stage. I mean, you could be if you wanted to build it, but why would you want to do that? You're a human as well at the end of the day. We've got some other interesting questions come through. Hi, John Hardy. Great to have you online. I can see the benefits in traceability in the supply chain, training, etc. It's very cool if applied with empathy, and that's a great word to use. How do customers tend to justify the ROI?
So the ROI is typically justified based on, for example, there's a couple of areas. One of the ones we're seeing the most at the moment is right first time production. Okay, so if the little Tamagotchi is able to go, hey, you forgot to do this, then you're no longer producing a defective product. And by that very fact, you're reducing the scrap and so on. The traceability side, I see in John's comment is the one that I briefly alluded to early on. But of course, the other one, which is one that's most interesting to me personally, is the training, retraining, and the retention of skills, manufacturing skills within the human population, rather than just trying to automate everything straight away. And because that is a lot harder thing to argue. It's like, okay, how it's almost conceptual. How is the system going to suck up the skills and then give other people basically give other people the skills to be able to to do this in a rapid way? And one of the things to note is that because it automatically segments and is able to disseminate videos depending on where it sees potential issues and so on. What that means is that people are able to be retrained if, let's say, a better manufacturing method is found by, let's say, an operator working in isolation who suddenly figures out this amazing way to do something that everybody else was just following this, the SOP. But that is a much harder thing to justify up front. But I think as we see more and more people leaving manufacturing, and as we see, greater skill deficits, we're going to see a much easier way to be able to justify that. Because, like, if you leave it, you'll lose it. It's that kind of argument. It's hard to put a bottom line on that at the moment. Hello, is there a delay?
I think Paul lost connection.
Oh no!
Uh-oh.
It was either deep in thought or frozen connection.
Talk
Right?
amongst yourselves. Listen, we've had quite a long time on that. Joe, do you want to? Can you see if explore if it's possible you can take over the broadcast and do your presentation?
Sure, why not?
Thanks everyone for your questions. That was really good. If you want to continue the chat, I'm sure you can speak to Krste directly via his company website.
All right, how's it look on your guys' end? We good to go?
Good here, sir.
Try sharing your screen if that's what you want.
Yes.
Oh, Paul, we're back. Paul's back in the room.
We're back. The wind changed in my direction again.
We decided that we'd go with Joe's talk in your absence. I hope that's okay.
You read my mind, John. Thanks very much. I was literally clicking Joe and waiting for his screen to pop up. Joe, over to you.
All right. Well, hello, everybody. My name is Joe Sleppy. I am the CEO of Krste Energy, and we are currently producing a wire-like and flexible supercapacitor, which is a type of energy storage product. And just because there was a question asked earlier, this is a project that was originally theorized at a university in Florida. And we took that intellectual property, we took that research project, and we began to commercialize it. And now we are actually selling products. So it's been a very exciting 4 or 5 years, and really a great way to leave undergrad already knowing you have a job lined up, right? This technology can be used in a variety of different markets and applications, but the purpose of this presentation will largely focus on creating battery-free Internet of Things products, as well as wearable technologies. The other day I was reading an article from Entrepreneur Magazine, and it talked about how the future will feature all of this sustainable energy and clean tech through every level of the grid, from the big producers and solar farms down to the individual homes. In the same article, they talked a lot about the requirement of an advanced technological infrastructure to enable things like smart cities. And I know this is the direction that the world's heading, and I know that they're going to be using Internet of Things for not just clean tech, but also smart cities. But when I'm picturing this world of the future, I keep seeing something that is seamless and beautiful. The technology is out of sight, it's out of mind, and most importantly, it requires very little to no maintenance. One of the technologies that is going to play an important role in this world of the future is called a supercapacitor. Now, this is another type of energy storage product, and whenever you say energy storage, people tend to go straight to batteries. But batteries are not the world's most perfect, ideal energy storage system. In fact, batteries can have a few flaws that people tend to overlook because they don't have another option. And so supercapacitors are designed to deliver energy very, very quickly, a big burst of power. Batteries, on the other hand, deliver a little bit of energy for a very long period of time. The ideal energy storage system should feature both batteries and supercapacitors, not just one or the other. Yet that's how products are designed today, featuring one or the other. And we know that supercapacitors are perfect for complementing energy harvesting technologies like solar cells and solar panels, but also complementing batteries for use in clean tech systems as well as Internet of Things. But as I mentioned, there's the challenge. And the challenge is, where are you going to put all of the energy storage systems in the world of tomorrow? We have electric vehicles, exoskeleton suits, asset tracking, smart camera vision systems, solar power systems. And while we know that energy storage is needed in all of these places, in order to add more energy storage usually comes at the cost of reducing the cargo space in your electric vehicle, or maybe you have a big ugly box in the garage. And so the question we asked when we started this company is, where will the energy storage technology go? And one thing I point out in these images is every single one of these pictures, the exoskeleton, the solar panels power system, the electric vehicle, even the AR VR headset, each of these features some kind of wiring infrastructure. You might not see it, but there is cable and wire involved in each one of these. And that's why the innovation, which is to build energy storage into the wiring infrastructure of the world, right? And by doing this, we can actually miniaturize electronics. We can add new features to the electronics. We can improve performance, and we can hide energy storage into the infrastructure of the world. That way, we have these better systems. We have a more robust smart city. We have a longer lasting electric vehicle, things of these natures, but we don't have the typical eyesore that comes with adding more energy storage products. Our first product on the market is called the cable-based capacitor. This is a wire-shaped flexible supercapacitor, and that flexibility gives designers a placement advantage. Instead of putting supercapacitors on a printed circuit board or inside of a box that goes inside of a vehicle or something of that nature, we can integrate the energy storage elsewhere, off the circuit board, right? And we found that the supercapacitor, with its performance, which is typically to provide a burst of power or to collect intermittent sources of energy, is the perfect complement for both clean tech, renewable energy systems, as well as Internet of Things. And so we are currently focused on bringing this wire-shaped supercapacitor technology to use in the Internet of Things market. And what we found as a problem here is that batteries have a short service life, and that can lead to a very frequent and costly replacement. And the reason that they have a short service life is, one, the physics of how batteries are built. They generally have a short service life. Typically, we'll say 1 to 10,000 cycles, where a supercapacitor has 1,000,000 cycles, right? So dramatically different types of service life here. But what we found is that batteries can be damaged when they deliver energy quickly. This burst of power, which we can see in this graph here, comes from when you are wirelessly transmitting data. And when you wirelessly transmit data for a wireless IoT device, you have this burst of power, and this burst of power damages the battery and it shortens its service life. And so if an IoT system is deployed, every 2 to 5 years, you're going to be changing the coin cell batteries out in the IoT system, and that's expensive to do. And so what we started to think about is, can we replace this battery with something else? And the first thing that comes to mind, and it's a really popular growing trend right now, is to replace the battery with something with a long service life, such as a supercapacitor and an energy harvesting technology, right? And what that allows us to do is have the supercapacitor deliver the burst of energy for the data transmission. Meanwhile, the sleep state, or the data collection stages, can all be powered by an indoor solar cell that's sitting on the device in a smart factory, or perhaps it's sitting on a street lamp in a smart city, right? The combination of a supercapacitor with an energy harvesting technology can replace the battery, and that way you don't have to replace it every 2 to 5 years. It only has to be replaced once a decade instead, right? What we found is that this can lead to at least a cost of ownership reduction by about 25%. And this cost of ownership reduction comes from not having to pay a maintenance worker or a technician to go spend their time changing out these batteries. More importantly, what I'm more excited about is the wire-shaped form factor of our supercapacitor. Because it is not restricted to use on printed circuit boards like typical capacitors are, the supercapacitor can instead be integrated into the cable, as shown in that image in the middle towards the bottom, right? By having this capacitor integrated into the cable, there's more space available on the circuit board, which means you can either add new features to distinguish yourself from your competition, or you can offer a smaller product. And just to give you an idea of this, the image on the left is a typical asset tracking device. And the image in the middle shows what the circuit board looks like a lot of times for these energy harvesting products. And you can see that big blue box there, which is highlighted in red, is what a traditional supercapacitor looks like. It's taken up, what is that, about 50% of the space on the circuit board. And this space on the circuit board could be used to do something else, to add more value, do something different. And so if there was not a supercapacitor on the board, what features would you add, right? Would it be additional connectivity? Maybe it's more sensors. Maybe it's faster computing time, right? This gives designers the ability to do new things, unlock additional innovation without having to sacrifice the supercapacitor. And that's because the supercapacitor is installed in the leads that come out of the solar cell, right? So on the image on the far left here, you see there's a solar cell, but the solar cell isn't just there, it's connected to the circuit board, and it's connected through these little wires, these leads and terminals. The image on the right shows our supercapacitor integrated in with these leads and terminals. That way you can have a solar cell and a supercapacitor, but both of the technologies are not taking up space on the circuit board. Like I said before, allowing you to either make the circuit smaller or to add additional capability and connections and things of that nature. The other area that we're seeing a lot of use and interest and excitement for our technology is in wearables, especially wearables that are combined with Internet of Things capabilities. And we really see this getting very popular in healthcare monitoring, as well as manufacturing, trainings, and games, which is what we just spent the good part of 40 minutes talking about, as well as typical consumer products. And so we did a little demonstration, this was actually very early on. We were just curious how this would work and if it would work. And so we had a goal. We knew that the senior citizens will a lot of times wear these fall alert detections. And this is just a necklace with a button on it. And when you press the button, an alarm will go off that might be on the other side of the house. So the person you're living with might know that you've fallen and need help. And our goal here was to replace the battery inside the SOS button with an energy harvesting device and a supercapacitor. And so what we designed is we integrated the cable-based capacitor as the necklace itself, right? So the necklace going around the user's neck actually is the energy storage technology, right? That gives us a much more real estate and area and volume to work with rather than being restricted inside the pendant. Also, we added some solar cells on the outside so that the supercapacitor will be recharged. And what we did is we used a power-filmed indoor solar cell. This is a solar cell that's sensitive enough to collect ambient lighting from, an office for a lighting, especially if you're in like natural light, such as, you're 10 feet away from a window or something like that. This design worked really well for that scenario. And we connected 3 units of our cable capacitor, flexible supercapacitor, into the necklace. So the necklace that's being worn by the user. And then we used EPs as a power management circuit. And what we found is that we were able to completely replace the coin cell battery inside the pendant, which means that pendant could maybe be smaller, but also the pendant doesn't need to, the user doesn't need to worry about changing that batteries. Maybe they have dementia and don't remember to, or maybe they have arthritis and it's difficult for them to. And so we wore this device for a day working around our office, and we walked outside to get the mail. We came back inside. We pressed the button randomly throughout the day to see, what's the voltage, what's the voltage drop? Are you able to use this without worrying? And so we found that even when you were inside of a dark room, when we were watching a presentation, that the capacitor was able to hold its charge, right? And when you were, out at lunch or getting mail or sitting around the office in indoor lighting, you're still able to, slowly charge that capacitor. And so we found that this concept of using a supercapacitor with an energy harvesting technology can in fact replace these coin cell batteries. And in our opinion, that makes a safer design. This is not quite just where it ends though. We can also look at this as, instead of using a solar cell, we could use RF energy harvesting. We could add a primary battery as an emergency backup. But really there's a lot of other opportunities to be integrating energy storage into. Perhaps it's inside the safety strap that goes to smart glasses for a manufacturing operation, or maybe it's in an AR/VR headset trying to go from a 2-hour battery life to a 10 to 15-hour battery life. Maybe it's inside the headphones, or maybe it's the strap that's sitting on top of Paul's sound canceling headphones, right? So the concept here is to integrate additional energy storage, specifically something that's high power that can complement batteries, so that users have a better experience, that IoT operators don't have to change batteries as frequently. And even for our ambitions are a little larger than that, such as building supercapacitors into the wiring infrastructure of an electric vehicle so that we can complement the batteries there as well. And so this is where we're starting with our technology, and we're very excited to see where it goes. Paul, I think you're muted.
Thanks, Joe. Well observed. Just bringing everybody else back in there. We had a couple of questions pop through as you were giving your talk, which was absolutely fantastic. First one from Prasad. If the capacitor is engaged, how long will the power be delivered for?
Yeah, so that's going to depend on the load, right? And so if you take our capacitor and you're just powering something that is drawing, 1 milliamp, the one unit of our capacitor, which I've got a sample here, right? I'll show you. Go ahead and bend it however which way you need it to be bent. One of these delivering 1 milliamp, we would be doing that for minutes, hours, right? But what a supercapacitor is designed to do is deliver an entire amp or 2 amps to send a 5G wireless transmission over a really far range. That would significantly damage the battery, but the supercapacitor is going to be able to deliver that for 100 milliseconds to 500 milliseconds, which is plenty of time to send that data transmission, right? And so this is all about pairing supercapacitors with energy harvesting technologies to have the supercapacitor provide that burst of power, which is a very short period of time, and have the energy harvesting device power the sleep state or the 1 milliamp type draw.
Yeah, brilliant. Thank you. John Hardy. Hi, John, again. What is the cost per meter?
Actually, our product is available on Mouser Electronics, which is a typical distributor. Right now, 120 millimeter long device, which is 4 or 5 inches or about 12 centimeters, depending on where you are in the world. This is being sold on Mouser for about $16 right now. Having said that, we started production a couple months ago and are currently in the process of significantly scaling up our production capabilities, which will see that retail price falling quickly. Of course, there's quantity scale orders and things like that that bring discounts in as well.
Yeah, awesome. We've got another one from Andy Bush. Hi, Andy. How long can a SC hold its charge for?
Yeah, I think a SC is going for a supercapacitor there. So the supercapacitors are going to charge up, and they're going to have a little bit of a leakage. And so over, I would say maybe 24 hours, you're going to see about 25 to 45% of the potential, the voltage drop. So they will lose their power once, if they just sit ambient and just wait. But typically these supercapacitors are going to be designed to charge up and then deliver that energy very, very quickly and then be recharged when the next scenario comes. Yeah. As for energy density, that's the big difference between batteries and supercapacitors, right? So this is a perfect point to bring up, Andy. Batteries are going to have a very rich energy density, but they're not going to have a very good power density. This is why when they have to deliver that burst of power, such as sending a data transmission, the battery can be damaged. Meanwhile, the supercapacitor has the exact opposite problem. It has a terrible energy density, but has a really good power density. So my argument is you put both batteries and supercapacitors together to get a good energy density and power density. Or perhaps you put a fuel cell with a supercapacitor to get a good energy density and power density. One thing to keep in mind though is with a traditional supercapacitor, you're going to add that supercapacitor to your battery bank. You're either making a larger battery bank, which might mean your circuit board or your product and system is getting larger. Or if you're an electric vehicle, for example, maybe that means giving up some of the cargo space, right? So there's a negative engineering trade-off. Or it means you're going to use fewer batteries, which means you're going to have a shorter runtime, or it's not going to last 2 weeks. It's only going to last, 1 day, whatever it might be. So typically adding traditional supercapacitors to a battery bank or something of that nature comes with a negative engineering trade-off. With our design, the flexible supercapacitor, we're able to integrate the flexible energy storage supercapacitor into the wiring, connecting that battery to a load so that there's not this negative trade-off. Instead, it's integrated into a part of the system that already exists rather than having to add another big block of something on top of what is already existing. I hope that makes sense.
Awesome. Another one from John Hardy. How robust to damage are the supercapacitors from a digital supply chain perspective? Could it be built into a tape or label?
Yeah, so regarding the robustness to damage, that is one-on-one what supercapacitors are great for. You can charge it, discharge it randomly. You can, discharge it at a really low current, at a really high current, and the supercapacitor is not going to mine. The only thing you have to be careful of is the voltage rating. That's true for batteries. That's true for supercapacitors. That's true for pretty much any electronic component, right? And so I would suggest designing in a little buffer for voltage rating, of course. But for a digital supply chain perspective, could it be built into a tape or label? So actually, we're waiting to hear back from a grant where we will be more or less turning our supercapacitors and integrating them into a solar cell tape that becomes a drop-in solution to batteries, so that there's no additional electronics needed.
Okay, so John was just clarifying. I mean, what happens if you chop it in half?
Yeah, don't cut our capacitor in half. If you have our capacitor here and you cut this in half, what's going to happen is there might be a little bit of fluid that leaks out. Don't worry, it's more or less water. So it's not going to be dangerous, but you're going to break the product. It'll definitely be a short circuit when you go through that cutting process.
What is the leakage current compared to standard supercapacitors? Is the energy density equivalent?
Yeah, so our technology, when we started this back in 2016, we were faced with a choice. Do we want to make a wire-shaped and flexible supercapacitor that will work, or do we want to spend 5 years doing advanced R&D to have the world's best flexible wire-shaped supercapacitor that is also the world's greatest supercapacitor? And the path that we took to start was, let's just make something that works, and then we'll go adopt better and better energy storage materials. So currently, our energy density, our leakage current, all of that is going to be very similar to what is already existing on the market. It's just going to be a flexible wire-shaped version. What's the next step, which is what we just started doing in the last couple months here, is adopting additional more advanced materials such as alternative graphenes or activated carbons or maybe ionic liquid electrolytes, things of these natures, which will then boost the voltage rating, increase its capacitance, and also be able to do things like reduce the leakage current. One thing that I think is really cool on that topic of comparing us to a traditional supercapacitor is supercapacitors' capacitance is actually proportional to the surface area. And by having a coaxial cable form factor, which is what the CBC is, the coaxial cable form factor gives you about a factor of pi improvement in surface area for, we'll say, on a per volume level, right? And so the current product that we have here, this one, the capacitance is a minimum of 3 farads. But also, if you use a very low current, for example, if you're going to charge it with a 1 milliamp, you might see something closer to 6 farads.
Cool. In the 12 centimeter unit you described, what is the capacitance? Yeah,
it's going to be a minimum of 3 farads, and for if you use a really low current, like 1 milliamp to charge it, 2 milliamps to charge it, whatever it might be, you're going to see something closer to 6 farads.
Okay, cool. I think that's it all from the ones that we've had from viewers. Please do share the show if you found this really interesting. We grow with your help, so I would really appreciate you sharing the links to this show and the great talks. Chris, John, any questions?
Yeah, there's a couple of things that I've been dying to ask, actually. First, the comment, I think on the how do you go from research to entrepreneurialism, I think often it's a moment like that when you have that realization like you did. I mean, that is just a beautiful kind of wow moment. My question, a couple of things really. The one application that in my mind perhaps screams out a little bit is the application to swarms of satellites and being able to potentially power the long-range communications or even some of the thruster technologies. That's one question. The second question is, could this be integrated into PCBs?
Yeah, absolutely. So, when it comes to the printed circuit board, there's actually a pretty cool. I'm looking for a prop to kind of try and help. So let me do my best here. If this is your printed circuit board, right? A traditional supercapacitor is going to take up a big block of space, or perhaps it's going to stand really tall, and then you have something like that where all the other components are really short, but you've got this really tall supercapacitor sitting on it. But with ours, you can route the supercapacitor through the free space. So maybe that's a 90-degree angle, or maybe you need to do something more like a U shape. The surface area that's going to be taken up on the circuit board by the supercapacitor is limited to the diameter of the cable, which in our case, our cables are about 6 or 7 millimeters long, wide. And so the surface area taken up on the circuit board is significantly less for our supercapacitor compared to what's being taken up by a traditional supercapacitor. In fact, the link that's sitting under my chin right now kind of goes through that and talks about how these placement advantages can be used for integrating the supercapacitor in unique places, such as into the wiring infrastructure of an IoT system, as well as putting it on a printed circuit board. But in short, you can take this and route it through free space available on that circuit board, or maybe you build components underneath it on the circuit board to try and maximize the usable real estate on that board.
Fantastic.
John, any questions?
Yeah, Joe, a couple of months ago when I looked into the issue, Mouser was showing stock issues, and I've just been on the Mouser website and it's saying unable to ship to the UK due to government regulations. Is there any movement to solve this issue, or do we have to buy it from Mouser EU or Mouser US?
Yeah, so right now it is only available in the US through Mouser right now, which we're working through to adjust that. I would say though, if you reach out to me directly, I can bridge those gaps and we'll use all the same pricing as Mouser would. So yeah, that is we'll say like I said, we started production a couple months ago. Mouser is a Texas company, and so we got it set up for the US pretty quickly, but we still have a few more things to do before it can be globally available on Mouser. Okay.
Also, is it possible via circuitry or whatever to work out how much charge is remaining in one of your supercapacitors? Like with a standard battery, you've got 50%, 25% left.
Yeah, that's a fantastic point, John. And actually, it's an advantage to the supercapacitor. When you have a battery, it doesn't matter if it's almost going to run out or not. It's going to have pretty much the same voltage. It might be a small window of, let's say for lithium ion, 4.2 to 3.6, right? You can't predict the state of charge as well. With a supercapacitor, the voltage and the life left is very linear, right? So you can actually see, okay, this is a supercapacitor that has a rating of 1.6 volts and it currently has 1 volt. Well, I can predict exactly how much energy using energy equals 1/2 CV squared to predict how much energy is remaining. So it's actually much easier to predict the capability of the capacity remaining in the supercapacitor compared to the capacity of a battery.
Okay, great.
Can you share the link with me for Mouser so I can share it with everybody, please?
Just sent it your way. I kind of predicted that was going to be coming. Yeah, so I did just share that, but again, if it's not available to ship in your area, just reach out to me directly, and you can send an email to hello@capacitechenergy.com or joe.sleppy@capacitechenergy.com, and we'll make sure that some samples are made available to you, and we'll just ship them directly instead of looking through Mouser.
That's awesome. Thanks, Joe. Guys, do you have any more questions?
Nope, all good.
All good. Excellent. Hey, Joe, Chris, John, as always, thanks very much. It's been an absolute pleasure, and really good show. Nice and a bit different, that one. Joe, really liked that one. Really going deep on the making of the things, which is always good. Thanks very much for your time. If you'd like to be on the show, talk about something that you're doing, please do get in touch with info@iotnorth.uk. Do check the website, join the forum, let's connect and talk. And of course, follow us on LinkedIn, YouTube, Facebook, whichever is your preferred platform.
So next month, before you cut us out, next month we should have Amy coming to AMEY, very large multinational company, coming to talk to us about all the exciting things they're doing in the IoT space. But they haven't sent me the details yet, so none of it's up on the website. We're hoping that's going to be in the next couple of days. So please check any of the IoT websites, Leeds, Newcastle, Manchester, or London, and details will be up soon, hopefully.
Brilliant. Thanks for the reminder there, John. We also have some stuff in the pipeline with Northumbrian Water as well. Hopefully Steve Blanks is watching this show and remembers to reply to my email from last week. Hopefully that'll get you stirred up to get in touch. Thanks again, Jonathan Greenwood. Great show. Thanks. And on that note, thanks very much and good night. Bye.